In this lecture, we will do a problem on metacentric height. There's a problem to find the metacentric height. So the question is, a solid cylinder of diameter 5 meter has a height of 4 meter. Find the metacentric height of the cylinder when it is floating in water with its axis vertical. And the specific gravity of the cylinder is given as 0.6. So let us draw the figure. So you have the cylinder here, and it has got a diameter of 5 meter and a height of 4 meter. You don't know how much it is submerged or how much it is floating. So let us take it as h, that is a portion, length of the portion below the water. So first you need to find h. So for that, first we will find the density of the cylinder, that is 0.6 into 1000. Because specific gravity is given as 0.6, so that is 600 kilogram per meter cube. Since the body is floating, according to Archimedes principle, the weight of the body, weight of the cylinder is equal to weight of the fluid displaced. Okay, so weight of the cylinder is rho into the total volume into G, and weight of the fluid displaced is rho of water into volume of the fluid displaced into G. So what is the total volume? That is, this is 600. The total volume is, say it has got a diameter of 5 meters, so cross-sectional area pi by 4 into 5 square into 4 into G, that is equal to rho of water is 1000 into the volume of water displaced is pi by 4 into 5 square into H into G. So you can cancel it off. So that means H is equal to 600 by 1000 into 4. So that means it will come out to be 2.4 meter. So H is equal to 2.4 meter. Now, what is metacentric height? GM. The formula for metacentric height is I by V minus BG. See, center of buoyancy will be here, that is it is a height of see, the total height is 2.4 meter, so this will be 1.2 meter center of buoyancy, and center of gravity will be here. That is at a position of 2 meter. That means total length is 4, so it is up to, it is 2 meter. That is 2 meter. Now that means BG will be equal to 2 minus 1.2, that is equal to 0.8 meter. And what is I? See, I here is, see, on the top view you can see that this is a cylinder, so you need to find the moment of inertia of the top area about this axis. So I here will be equal to I here is equal to pi by 64 d raised to 4 is the moment of inertia of the top view. So this is equal to, and the volume displaced is equal to, right, so I is equal to pi by 64 d raised to 4, and volume displaced is equal to, you know the formula, pi by 4 d square into h minus bg is 0.8. So that is equal to d square by 16 into h minus 0.8. So and d square is 16, so it is 16 divided by 16 into h is 2.4 minus 0.8, and this is equal to, you will get it as minus 0.38 meter. See, you are getting a negative value for metacentric height. So metacentric height is equal to minus 0.38, which is less than 0. That means metacenter is below the center of gravity and the body is unstable. That is what you can infer from this value.